beautiful. They've stopped doing this. What you see there is what likely was an upset emission. So in Houston, all the petrochemical stuff is along the ship channel, which is that blue vein extending east of Houston, and into Galveston Bay, which is the notch there just to the southeast of Houston. So probably what happened, there was an upset emission. So some petrochemical plant let off some hydrocarbons. And they drifted over the city to the northwest and interacted with the urban NOx plume coming from cars. And that just intensified, the ozone just intensified as it moved across the city in the afternoon to some unhealthy levels. And this, folks from Houston, this happens, this is a not unfamiliar pattern. Hydrocarbon emission, there's lots of NOx, and we create lots of ozone. There's several processes that can introduce ozone into the troposphere. One is mixing down of ozone-rich air from the lower stratosphere, and that happens with folds and fronts where the tropopause, a finger of the stratosphere sticks down to the troposphere, and conversely, a finger of the troposphere sticks up into the stratosphere. And then you get air exchange across these boundaries. Most of the time, the air sort of gets sucked back up into the stratosphere, but some of the time it gets irreversibly mixed into the troposphere. You're going to see in your profiles here that you've taken in the last few days some evidence of stratospheric exchange, or at least stratospheric intrusions into the troposphere. Biomass burning can produce carbon monoxide and NOx. Urban pollution produces all the above. And lightning and convective activity can also be responsible for NOx production, which leads to ozone production. And this is a cartoon that I used to sort of show the tropospheric chemistry, which is a little bit more complicated than the stratospheric chemistry. In the stratosphere, the sun breaks the O2 bond to free O atoms. That doesn't happen in the troposphere because that intensity UV radiation is not present. So you need another pathway to get free oxygen atoms. And the way it happens is an interaction of hydrocarbons and NOx in the presence of sunlight. And those interact with one another to free O atoms. And now the O atoms can react with O2 just the way they do in the stratosphere. And that's how you create lots of ozone. So it's a more complicated chemistry in the troposphere. You need hydrocarbons, which can come from anthropogenic sources. You need NOx, which can come from anthropogenic sources. You say the hydrocarbons can also come from natural sources. Trees, plants can be sources of hydrocarbons as well. The NOx comes out of power plants